All right, this video is over Law of Cosines. I'm going to go ahead and do both pages of Law of Cosines in one video because it's kind of short and a little bit easier than Law of Sines. And that way you don't have as many videos to go through. So Law of Cosines can be used to find side and angle measurements given two sides and the included angle, so side, angle, side, or all three sides. So no angle measurements are given and you just know the side measurements. This is different. So Law of Cosines is used to find a different set of information than Law of Sines. If you think back to Law of Sines, it was used only for angle side, angle side. So the side was out of the angles, or angle side angle. So the side was in between the two angles, or side angle where the angle was again outside of the two sides that you were talking about. And then this one, we have the opposite setup. You have side, angle, side, so the included angle and the three sides. So there are basically three formulas for finding things using the law of cosines, but it is the same formula over and over. So based on what you're trying to find is just the one you're going to use. So if you have a squared, then that equals b squared plus c squared minus 2 times bc times the cosine of a. So this is related to Pythagorean theorem because it's got the a squared, b squared, c squared. And then whatever side you're trying to find, then you are looking at the angle opposite of it. So that's a squared and cosine of big A there. All right, so then if you were trying to find b squared or big B, then you would use this version, which is still very similar. So you would have b squared plus a squared plus c squared, or equals a squared plus c squared, minus 2 times ac times the cosine of b. And then you probably can guess that the last one is c squared equals a squared plus b squared minus 2ab times the cosine of c. So even though it looks like there are three different formulas there to use, it's really just one, depending on what you're trying to find. So these first three, we're trying to find a side. So it is the situation where we have side, angle, side, and then we're trying to find the other side. And this is kind of the easy version of this because all of your information goes to the right side of the equal sign and what you're trying to find is on the left. So in this situation, we're trying to find x. It is opposite of 71 and we know the other two sides. So what we would set up is x squared equals 9 squared plus 23 squared minus 2 times 9 times 23 times the cosine of 71. So all of our information from that triangle go into the formula to the right because what we're trying to find is just x on the left. So you can literally type all of that into your calculator at one time. It's wonderful. Just be really careful that you are typing what you mean to type. Definitely before you hit enter, look at what you've typed and make sure you haven't made a mistake. Okay, so then x squared equals 475.2148. And then we got to round our final answers in there's 10th. So you can go ahead and do the square root of that answer. That will give you the most accurate side length. So that's 21.8. This is a side length, so no degrees. And you're done. So right here, if you want to, you can say that you're doing the square root. But obviously that's what you did since it was x squared and now it's just x. All right, for the next one, we have the same setup. X is across from 39. We know 15, we know 17. We're trying to find X. So we're going to do X squared equals 15 squared plus 17 squared minus 2 times 15 times 17 times the cosine of 39. All of that business goes in your calculator. So double check, make sure that you typed in everything correctly. So that's 117.6556. And then when you do the square root, you get 10.8 is the length of the missing side. All right, on number 3, we do have just the information and no triangle. I highly encourage you to use the space there to draw a triangle. It just will help you get everything in the formula in the right place if you can see how they are related to each other. So we've got, well, I don't know why that zoomed out like that. A, B, C. And so we know angle B is 106. We know AB is 10, BC is 7, and we are trying to find AC. So it's still set up like 1 and 2, but just having that triangle there visually helps you to be able to make sure everything's in the right place when you go to put it in your formula. So we have x squared equals 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 106. Okay, since this, we put it in, definitely just take a minute and make sure that you got it all right. Then go ahead and type it in. Okay, so 10 squared minus 7 squared times plus 7 squared minus 2 times 10 times 7. All right, so this is 187.5892. When we do the square root, you get 13.7. And then that is that side length. Okay, so then starting with number 4, we've been given all the side lengths and we have to find the missing angle. And if you have all the side lengths, you can literally find any missing angle using the law of cosines. So we could just use this formula over and over, and we could find y, we could find z. So whatever you needed to find, you can find it as long as you have all these side lengths. The way that we set this up, though, you have to make sure that you have all of this and this one thing on the left, it has to be the side length opposite the angle. So that's the part you've got to be sure that you get right when you do this. So we're going to have 8 squared equals 10 squared plus 11 squared minus 2 times 10 times 11, times the cosine of x. So that's what we're going to end up having to find by using inverse cosine here in a minute. Now, you have to be careful with this. You cannot type this all in at one time because part of it is multiplied, part of it is added and subtracted. So, of course, we know 8 squared is 64. And then you can do these two guys together and this part together in order to make an equation that you can solve. So 10 squared plus 11 squared is 221. And then you're going to have minus 2 times 10 times 11 is 220. And then times the cosine of x. So what you need to do now is understand that you're going to have to divide here, so you've got to subtract the 221 first. So I'm going to have 64 minus 221. So that's going to be negative 157 equals negative 220 cosine x. Now I'm going to do negative 157 divided by negative, whoops, that's not negative, 220. So that's going to give me 0.71364 equals the cosine of x. Got a little too fast there. So that means we're going to do the inverse cosine of that answer and get that x equals 44.5 degrees. So this is an angle, so the answer is in degrees. So I didn't write that step down of using the inverse cosine. I can if I need to. So we know that x equals the inverse cosine of 0.71364. And so then that's how we get that x is the 44.5 degrees. Since this is a little bit more work in there, I'm going to put a box around my answer just so that you can find it. The other ones are very straightforward. X is at the end and you can tell what that is. Okay, let's go on to the next page and do these other triangles. Same setup. You got all the sides. You're trying to find an angle. The angle that we're trying to find is across from 16. So we're going to have 16 squared equals 13 squared plus 5 squared minus 2 times 5 times 13 times the cosine of x. So 16 squared is 256. And then you're going to have 13 squared plus 5 squared. So that's 194. And then you're going to have 2 times 5 times 13, 130 cosine of x. So then you're going to do 256 minus 194. So that's 62. And then you're going to divide by negative 130. Whoops, I left out the 1. So that's going to be negative 0.4769 equals the cosine of x. So that means x equals the inverse cosine of negative 0.4769. Which, of course, you're just going to do in your calculator, do inverse cosine of the previous answer. And so you get that x equals 118.5 degrees. So that's how you would do that one. Again, it's not that it's difficult. It's just a couple of more steps than finding the missing side. And then here we've got one where you just have all the information and you're trying to find angle L. So it's really important here because you've got to make sure you have the right side length on the left side of the equal sign to draw that triangle. So just do that. And we've got L, M, N. And so we know L to M is 25. We know M to N is 20, and we know L to N is 24, and we need to find L. So that means we need to have 20 squared in the front of the equation. And then we're going to have 25 squared plus 24 squared minus 2 times 25 times 24 times cosine of x. And so 20 squared is 400. And then we got 25 squared plus 24 squared is 1201. And then we're going to have minus 2 times 25 times 24. Whoops. See, make sure that you're typing what you mean to type. So that's 1200. And then times the cosine of x. So we're going to do 400 minus 1201 And then we're going to divide that by negative 1200. So that is 0.6675. So that means that x is going to be the inverse cosine of 0.6675. So inverse cosine of the answer. So x is a 48.1 degree angle. Okay, so the last little bit here, we've got 3 problems that are application problems. So kind of, why would you need to have the law of sines or the law of cosines in the real world? So this is asking us to find the side measures to the nearest tenth and the angle measures to the nearest degree. So that's a little bit different than before. This says Maple Street, Oak Street, and West Avenue intersect to form a triangular piece of land. The angle formed by Maple Street and Oak Drive is 79. If Maple Street section is 390 and the Oak Street section is 250, find the length of the West Avenue section. So definitely draw this picture. Okay, so I'm going to say that this is Maple, and this is Oak, and this is West Avenue. So the angle formed by Maple and Oak is 79. So this one is 79. Maple Street is 390. Oak Street is 250. What is the length of West Avenue? Okay, so that means that we're going to have W squared equals 390 squared plus 250 squared minus 2 times 390 times 250 times the cosine of 79. So this is one that we can just type the whole thing into the calculator and find out what it is. So I'm just going to type all this in at once. It's going to be some big numbers with these lengths squared. 250 minus 2 times 250 times 390 times the cosine of 79. So W squared is 177,392.2, and then we're going to do the square root of that answer. So West Avenue equals 421.2 feet. Okay, so that is the answer to that one. So that one was one we were finding a missing side, so it was easy. We could just put it all in and then take the square root. Number 8 says Jack and Tom start at a tree and begin running apart with an angle of 23 degrees between them. If Jack runs 50 meters and Tom runs 38 meters, find the distance between them. Okay, so what we have here is we have a situation where they are running away from their starting point. Every time I do that, I mess it up. Okay, that's a little better. So we've got Jack running here, Tom running here, and then this is the distance apart they are at the end. So we know that when they start running, they're running 23 degrees away from each other. We know that Jack runs 50 meters and Tom runs 38 meters. So we need to find that distance between them when they stop running. So we're going to do distance squared equals, and I did a capital D, but I definitely should have done a small one. I just did that because I was using J and T for Jack and Tom. So then we have that that's 50 squared plus 38 squared minus 2 times 50 times 38. And then because somebody there was with had a protractor, they know that they were running 23 degrees away from each other because that's real life. So then we're going to do 50 squared plus 38 squared minus 2 times 50 times 38 times the cosine of 23. Let me look and make sure that was right because I did make a little mistake. Okay, so that's 446.1. Well, we'll just do 0816. And then we're going to do the square root of that answer. So the distance between them is 21.1 feet. Oh, nope, that's meters, not feet. So that is that problem. Okay, the last one, we're going to have to find an angle measurement. So this one says 2 radar stations are 2.5 miles apart and they're tracking an airplane. The straight line distance between the station A and the airplane is 7 miles. The straight line distance between station B and the plane is 9 miles. What is the angle of elevation from station B to the plane? Now this is more of a real life problem where you actually need to find that angle because the distance is easy to measure. The legs are easy to measure, whereas the angles are not. So I like this problem better for a real life situation. Oh, I held that too long. Let me start over. So you've got a station here tracking a plane in the air and a station here tracking a plane in the air. And you want to know this distance. No, and you know the distance between them, so you're trying to find the angle of elevation. All right, so if we've got station A and station B and a plane, okay, those are the things that we have. And so they are 2.5 miles apart, A and B are. And then the distance between A and the plane is 7 miles. The distance between B and the plane is 9 miles. What is the angle of elevation from station B to the plane? So you want to know angle B is what you're trying to find. All right, so that means that you are going to use 7 as your start on the left. So you're going to have 7 squared equals 9 squared plus 2.5 squared minus 2 times 9 times 2.5 times the cosine of x. All right, so we've got 49 here, and then we're going to have 9 squared plus 2.5 squared. So this first one is 87.25. And then we're going to have 2 times 9 times 2.5. So that's 45 cosine of x. So we're going to go back and do 49 minus 87.25. So that's negative 38.25. And that's going to equal negative 45 cosine of x. So then we're going to divide by negative 45. So you get 0.85 equals the cosine of x. So x equals the inverse cosine of 0.85. Except that's not what I wrote. So we're going to do shift and do inverse cosine of the answer. And so that angle of elevation is 32 degrees. Remember, they wanted us to round to the nearest degree on that. So it's 32 degrees. Okay, so those are all really good problems for law of cosines. I personally like it more than law of sines because there's no ambiguous case. It is what it is. But the law of sines is necessary if it doesn't fall into a side angle side or a side 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 situation.